Hello, ladies and gentlemen, and welcome back to more of the 2001 Cayley paper. We're just starting Part C. Those are the challenging questions, the 5 final questions on the contest. So we'll be doing question number 21 in this video. Point P is on the line y equals 5x plus 3. The coordinates of the point Q are 3, negative 2. If M is the midpoint of PQ, then M must lie on the line. Okay. So we're given a bunch of lines here. So we know the coordinates of Q, and then we have P is just somewhere on this line. Okay, and it can really be any point on that line. In fact, if we take each individual point P on that line and find M for each P, we'll trace out another whole line. So if we draw our picture here, Q was 3, negative 2, so we'll say it's down here. And I think our line went through 3, and it was going at a rate of 5x plus 3. Okay. Yeah, 5x plus 3 right there. Okay. So P is somewhere on this line. I have no idea what the value of P is. And that's part of what's going to help us answer this. Because P is just some other point on this line, there's a lot of different P values that we could have. We have a P up there, we have a P down here, P here, P right here at the intercept. We're going to have a whole bunch of them. And then we connect up to Q. We create the line segment PQ. And then on each of these, we have our midpoints M. And this gives us a line that M is on. Okay. So the best thing to do is, well, if you're unfamiliar with the way this works, you might try actually finding some values of P. Like, let's say x equals 1. You'll get 1/8 is a value of P, and you'll get a value of M. And what we can do is we can find enough values of M that we should be able to rule out all but one of these. So you could try enough values of P and find the values of M, and you could rule out all of these. That's certainly one way to go about doing this question. It's a good way, too. But another way to do this would be to take just our general form of P is going to look like x 5x plus 3. Okay? So we could find some specific values, but in general, M is going to be the midpoint. How do we find midpoints? If you have the line segment PQ, midpoint is just the average of the coordinates. So the average of the x coordinates and the average of the y coordinates. Okay, we can simplify that a little bit. X plus 3 over 2 and 5x plus 1 all over 2. Okay. So, this is in general what M is going to look like. And we would like to plug this into some sort of an equation. So, what we might do is say, let the line M lies on be y equals, sorry, capital M, be y equals mx plus b. You know, the general form of a line. I noticed that, all of these solutions, they're all given in the form y equals mx plus b, so the y-intercept form of the line. So let's say that it in general looks like this. Well, each point on M must satisfy this. So, in fact, a smarter thing to do, just to make this a little clearer, might be to say a generic point on P looks like, a generic point P on the line looks like this. And so for each P, we'll have this midpoint here. P plus 3 over 2, and then 5P plus 1 over 2. So we'll just clear this up a little bit. So no matter what value of P I have, I will get a midpoint, and that midpoint should be on this line. So regardless of what value of P I use, I should have this equation satisfied. Now what's really important here is that any value of p gives us a midpoint, or any point p gives us a midpoint, and that should lie on the same line, which means b should have no p's in it at all. So when I expand this out and I get mp plus 3m over 2, I get a constant here, and I have a 5p over 2 plus 1 over 2 here. Well, just like when we compare coefficients on a line or a quadratic, we can say that all the terms involving p have to be equal. So that means 5 halves p must be m halves p. And 1 half must be the same as 3 halves m plus b. Well, you can take this first equation and we can pretty clearly see that m is going to be 5. So already we know that our midpoints lie on a line with a slope of 5. Well, how many answers have a slope of 5? B and E. Okay? So right now we've narrowed it down to 2 possibilities, B and E. And if you ever find yourself in a situation on a Pascal, Cayley, or Fermat where you've narrowed it down to 2 possibilities, feel free to take a guess if you run out of time. But now we can substitute this m equals 5 into this equation, so 1 half is going to be 15 over 2 plus b. Okay? And we can rearrange. We'll get minus 14 over 2 is equal to b, or b is equal to negative 5. So our line will be y equals 5x minus 7. And that was E, but we'll just double check really quickly. Yes, it was E. Okay. So that does it for question 21. It's a good little question. I like it. I think it was on the Fermat or the Pascal, one of those two. But I don't remember off the top of my head. But it was a nice question. And I look forward to question number 22. And hopefully you're looking forward to question 22 as well. And we'll take a look at that in the very next video. So thank you guys so much for watching, and I'll see you in the next video.